Let's start this section by simplifying this rational number. We've got 16. Now the square root of 100 I can write as 10 squared. So I'll get 16 times 10, which is 160. So our question is 16 square root of 100 in simplest form? No, it's not, because I can take the square root of 100. All right, so the answer to the question that's being posed is no. Now I want to simplify this number here. Now, first of all, it's going to be negative something. So what is this part right here? Well, the first thing I see is I've got the square root of a negative, so I'm going to take an I out. Now I'm left with the square root of 64, and I just happen to be able to do that. So I'll get I times 8, or how about negative 8I? Now let's simplify this number if we can. We've got negative 8, and then I've got that minus sign, and now I've got this. Well, it's the square root of a negative, so the first thing I'm going to do is take an I out. And the square root of 25, I can actually do that. So I'll get 5, and I'm just going to rewrite it as negative 8 minus 5I. And this is in the proper form because this is in form A plus BI, where I've got the A right here, that's the real part, and B, negative 5, is the imaginary part. So if I write it here, A is equal to negative 8, B, the imaginary part, is negative 5. Not negative 5I, just the coefficient of the I, negative 5. Now in this one, we've got the square root of 11, which is a real number, minus the square root of negative 3. Now this is an imaginary number. There's not much we can do with this. I can take an I out, but I don't know the square root of 3, so I'm going to have to leave it like this. Square root of 11 minus I square root of 3, and I'll leave it just like that. Now what about this one? Well, first of all, we're going to have the 2 minus. Now what about this negative square root of negative 12? Well, first of all, I see it's square root of a negative, so I'm going to take an I out. Now what about that 12? I can write that, I can break that down into two numbers where I know the square root of one of them. I know the square root of 4, so I'm going to break it into 4 times 3. This will give me 2 minus I, square root of 4, square root of 3, if I break it apart. And this right here I know is a 2, so I'm going to write 2 minus I times 2 times square root of 3, but I'm just going to rewrite it like this, 2 minus 2I square root of 3. And this is the form A plus BI, where A, the real part, is 2, and B, the imaginary part, is, now be careful here, the I does not come along with it. What's the imaginary part? What's the multiplier of the I? The 2 and the square root of 3. So this is going to be negative 2 square roots of 3. Now number 6, we've got square root of a negative here, square root of a negative here. So this is imaginary, this is imaginary. Let's take the I out, and in fact, you know the square root of 9, that's a 3. So this is going to be 3I plus, and now this one, take the I out, but you know the square root of 4, it's 2. So you get 3I plus 2I, so 5I, a purely imaginary number. And if I write it in complex form, I'll get 0 plus 5I. Now that's the form A plus BI, where the real part is 0. The imaginary part is that multiplier of I, which is 5. Now number 7, we're adding two complex numbers. I've got that complex number added to this complex number. Now just treat these as if they were polynomials. So I'm going to have the real parts and then the imaginary part. So I'm going to get, I'll write in parentheses here, I'll get 7 plus 8 plus, and then the 6 minus 4I. All right, so what I'm doing is I'm taking the 7 plus the 8, the real parts, and then I'm adding the imaginary part, 6, and then minus 4. So we're going to get 15 plus 6 minus 4 is 2I. Now I've got this complex number added to this complex number. The first thing I'm going to do is try to eliminate these square roots of negatives. So right here, square root of negative 1, well, by definition, that's what I is. So I'll get 6 minus I, right? I is the square root of negative 1, plus negative 17 minus, now, I've got a square root of a negative, so the I is going to come out, and it turns out the square root of 361 is 19. Now, if you didn't know that, you just put in square root 361 on your calculator, and that'll show it to you. So this is an I, and then I get to 19. So how about 19I? And now add the real parts together, and then the imaginary parts together. So we're going to get 6, I'll write it here, 6 minus 17, right? 6 plus negative 17, and then plus, all right, negative I minus 19I. So I will get negative 11 minus, now it's plus, but here's what I get. I get negative 1I minus 19I is negative 20I. There we go. We have a multiplication here. Now, this is a complex number, right? That's a complex number, but just treat it as if it were a binomial. So just use the distributive property. 9 times 4, all right, 9 times 4 is 36, minus 9 times 7 is 63I. And we have a multiplication here. Now, this number I can simplify right away. It's got a negative under the radical, so I is going to come out. Square root of 9 is 3, so how about 3I times 2 minus 7I. Now, distribute. 3I times 2 is 6I. And then 3 times negative 7 is minus 21. I times I, right? I got I times I, which is I squared. But by definition now, I squared, this is equal to negative 1. So we are going to have 6I minus 21 times negative 1, which will give us 6I. Negative 21 times negative 1 is plus 21. And I'm going to write it in this form here, A plus BI. I want the real part to come first, the imaginary part to come second. So I'm going to write this, just turn it around, 21 plus 6I. I'm going to do another one that's similar to number 10. Square root of negative 49, well, square root of a negative, I'll get an I. Square root of 49, we know, that's a 7. So how about 7I times square root of 6 minus 4I? Now, just multiply through using the distributive property. So I'll get 7I times square root of 6. Square root of 6 I can't do anything with, so how about just 7I square root of 6, and then minus, right? Now this is going to be distribute. 7 times 4 is 28, and then I get I times I. So I'm going to get minus 28 minus 28. I times I is I squared. But I squared, we know by definition, that's equal to negative 1. So now we're going to get 7I square root of 6 minus 28 times negative 1. Well, this will give us positive 1. So how about 7I square root of 6 plus 28? And then I'll write it in the form A plus BI, where the I, the term with the I, is going to come second. So I'm just going to switch these around, switch the order. Commutative property of multiplication. So about 28 plus 7I square root of 6.